Hi, hello. Welcome back to the session on course on mechanical measurements. I'm Nilambika N from the Department of Collegiate and Technical Education. I'll be discussing today a unit 2, that is transducers and strain gauges. This is session number 5. So before we let into the session 5, we shall summarize whatever we have learnt in the session 4. The first thing we saw in the session 4 is piezoelectric effect. I already said there are certain materials, whenever your force is applied on those material, it is converted into the voltage. Conversely, if we apply the voltage to the same material, so there we have seen there is change in the dimensions in those materials. So such effect we call it as a piezoelectric effect. And the second thing we saw was certain piezoelectric materials. We saw there are two types of piezoelectric materials. One was natural materials and another is synthetic materials. So in some of the natural materials are quartz and tourmaline group minerals, and the synthetic are Rochelle salt, barium tetranate. So quartz is a commonly used piezoelectric material because of its stability. It is more stable compared to the other materials. And we saw Rochelle salt. It is gives very high output. If you take barium tetranate, we can form into any desired shape. We saw some other piezoelectric materials like topaz, sucrose, langasite, so etc. Next we saw some of the desirable properties of piezoelectric materials. First one was about its stability. It has high stable, and the second one is it has high output. So it gives very high output. And the next is it is insensitive to the temperature conditions. And the next we saw it is insensitive to the humidity. And the last one of the best desirable property of piezoelectric material is it has the ability to form into any desired shapes. Next we saw the piezoelectric transducer. So piezoelectric transducer is a device which uses piezoelectric effect to measure changes in the force, acceleration and so on. Next we saw some of the advantages and disadvantages of piezoelectric transducer. The first advantages of piezoelectric transducer is it has high stability. So it is stable with the changes in the conditions. The second one is it is of small in size. And the third thing advantages is it has high frequency response. For any parameter changes input, it would give suddenly output. So it has high frequency response. And the next advantage we saw is rigid construction, means it is made stronger in order to withstand rough handling. Even if you handle roughly, it doesn't affect. The one more advantage we saw is it is well suited for dynamic measurements. If you take for example there is a pressure variation continuously in the IC engine. So for one moment to the another moment continuously pressure changing. So if the input changes and the suddenly output is changing. So this is suited for in that conditions. Another Next we saw some of the disadvantages of piezoelectric transducer. The first one was the output is affected by change in the temperature. If there is any, because of the variation in the temperature, the output definitely it's going to affect. And the next disadvantage we saw is, as I already said in the advantages, it is suitable for dynamic measurements, but in the disadvantages is it is not suitable for static test. And the next disadvantages is the output is quite low. And we saw some of the sample questions from this session, from the session 4. Now let's start session 5. So there are, let's see the topics that are going to be discussed in this session. The number 1 is a new term we are going to discuss, that is strain. What is strain? And the next thing we are going to discuss strain gauges and measurement of strain. In the next we shall see what is the purpose of strain gauges. And the next we shall see the metal used in making the strain gauges, which type of metals they are using for the construction of strain gauges. The next we shall classify the strain gauges. And next we shall see some of the selection factors of strain gauges. So later we will see some of the sample question from this session, and we shall go through whatever we were going to learn in this session, that is summary of the session. And I'll be giving one assignment, and the next followed by MCQs, that is multiple choice questions. I'll be giving some multiple questions to you. You need to write down the answer. You need to guess the answer. Okay. Let's start with the word strain. Strain is simply a measure of how much an object is stretched or deformed. Okay. If you take any object, just think it is a measure of how much it is stretched or it is deformed. And strain doesn't happens automatically. So in order to strain happen, some force is applied on the object. Either it may be compressed or it may be tensile. So strain occurs when the force is applied on the object. It deals with the change in the length of an object. Either there will be increase in the length or it will be decrease in the length. So let's see with one diagram. This is an object which I am taking of having length L. Now I am applying force, that is tensile force. So when I apply a tensile force, at the end what is happening? The length is getting increased and the diameter is getting decreased. So length is increasing, it is become longer and it is becoming thinner. Now, so the extra length, that is delta L, it is a increase in the length. Now this happens within the elastic limit. Should not cross the elastic limit. If it cross the elastic limit, it would get break. Okay. Now strain is nothing but it is change in length divided by original length. That is change in length. How much change we got? Delta L. So delta L divided by L. So this is what about strain. I already said strain is simply of how much an object is stretched or deformed. Stretching and deformation doesn't happen accidentally. Something is going to happen before that. What is happening? For in an object, when a force is applied to an object, that time either if it is tensile force, stretching will take place. If it is compressive force, deformation will take place. Make sure everything happens within the elastic limit. After that, what is happening? There is going to be change in the length. Either the length is decreasing or the length is increasing. This is about strain. I hope you all understood what is strain. Let's go further. Next topic we are going to deal is strain gauges or measurement of strain. Strain gauges are used to measure the deformation of the object. So what is the function of strain gauge? These are used to measure how much deformation has taken place in an object. So now this is a simple strain gauge. So it is constructed from a single wire that is wounded back and forth. Right? These two ends are connected to the points where the strain has to be measured. So here it is soldered tab. Now when a force is applied on the wire is gets stretched. So when the wire gets stretched, so here the force is applied here. When a force is applied at this two, the wire get stretched. What is happening? When the wire gets stretched, the resistance of the wire going to get changes. Basically, it converts force, pressure, tension into a change in the electrical resistance, which can be then measured. Now, first is I am applying a force, then the force is going to change the dimensions of the strain gauge, then that change in the dimensions will give the result, how much force is applied. So next we shall see the purpose of strain gauges. So there are two purposes. The number one, to determine the state of a strain existing at a point on a loaded member for the purpose of stress analysis. That means we are measuring a strain in order to measure the stress at a point. So if you get the strain, we can measure the stress at that point, right? So determine the state of a strain at a point on a loaded member for the purpose of stress analysis. Now the second purpose is the strain. It acts as a strain sensitive transducer in order to measure quantities such as force, pressure, displacement, acceleration, or for the purpose of measuring magnitude of the input quantity. So this strain gauge acts as a transducer. What it is measuring? Force, pressure, displacement. How? By the input quantity. Okay, these are the two purposes of strain gauges. Now, next topic we are going to see the metals used in making of strain gauges. Which kind of metals we are using to make. So the strain gauges are made with constantan, nichrome, tin alloy, platinum alloy, copper nickel, nickel chrome, nickel iron, modified nickel chrome, platinum tungsten. So these are the some materials where strain gauges are made up of. The next we shall classify the strain gauges. Strain gauges are classified as this. Number one, mechanical strain gauges. Next, optical strain gauges. Third, photoelastic strain gauges. Fourth, electrical strain gauges. Fifth, rosette gauges. So these are 5 types of strain gauges. Number 1, mechanical strain gauges. Second, optical strain gauges. Third, photoelastic strain gauges. Next, electrical strain gauges. Next, rosette gauges. So for your syllabus, we are studying mechanical strain gauges and optical strain gauges in detail. Okay. The next thing we shall see the factors which are considered for the selection of strain gauges. The number 1, the first factor is high sensitivity. Okay, in order to select the strain gauge, it should have high sensitivity. For small input, it should be able to give the output. The next, it should be high electrical stability. For electrical stability must be high. The third, it should have high yield point. That means the material we are using, the strain gauge we are using, it should be always work under elastic limit. It should not cross the elastic limit. It should have high yield point. The next is it should have low temperature sensitivity, because temperature also matters. If the temperature changes and the resistivity also changes. So because of that, the low temperature, it should have low temperature sensitivity. Next, low hysteresis. So it should, the factors like friction, loose screw, backlash should not be there. So if you all that includes, again the output will be not improper. So because of that, the hysteresis should be low. It should have good workability. It should have good weldability. The joining must be good. The next, it should have good corrosion resistance. It should not be having corrosion. Okay, these are some factors which are considered for the selection of strain gauge. Let's see some sample question from this session that may be asked in end examination. Number 1, define strain gauge and list the purposes of strain gauge. The next question they may ask is, write the classification of strain gauges. Now we shall summarize the topics. First thing we saw, strain. What is strain? When an object, how much an object is deformed. That point we call it as a strain. Strain gauges, measurement of strain. What we saw in this? Strain gauges are those which is used to measure strain. So when an object, so if you take an object, right, either when a force is applied on it, either it expands. If your tensile force is applied, it expands. So thereby the length increases and diameter decreases. So which in turn increases the resistivity of the object. So if you apply compressive force within the elastic limit, if it doesn't deform, it broadens and it shortens, but its resistivity decreases. Now if you take these values, we can measure the strain. Later we are going to get the stress at that point. So what is the purpose of strain gauge? Purpose of strain gauge, first one is to determine the state of a strain existing at a point in a loaded member for the purpose of stress analysis. The second, it acts as a strain sensitive transducer for the calculation of force, pressure, displacement. So these were the purpose of strain gauges. The next we saw some of the metals used in making of strain gauges like constant ton, nichrome, platinum alloy, dynamo alloy, copper nickel, nickel chrome, iron nickel, modified nickel chrome, and so on, etc. The next we have saw the classification of strain gauges. Strain gauges are broadly classified into 5 types. Number 1, mechanical strain gauge. Number 2, optical strain gauge, photoelectric strain gauge, then rosette gauges. So these are classification of strain gauge. The next we saw some of the selection factors which are considered for the selection of strain gauge. First one is high sensitivity. It should be high sensitivity. Then it should have high yield point. Then it should have low hysteresis, low temperature sensitivity. Then it should have good workability. It should have good corrosion resistant. It should have good weldability. So these are the some of the factors which are considered for the selection of strain gauge. And the next we saw some of the sample questions from this session. So this is the assignment. List the applications of strain gauges. So where we can apply this strain gauges, where we are using this strain gauges. List out. Now let's go for the test. Okay, are you ready? I hope you all are ready to write the answers. Okay, I'll be giving some questions, MCQs. You write down the answer. Guess the answer. The first question is: a strain gauge is used to measure dash of an object. What is the purpose of strain gauge? What it measures? Okay. Number 1, option A, displacement. Option B, deformation. Option C, force. Option D, pressure. Which among these 4 is right answer? A strain gauge is a one which is used to measure. Is it a displacement? Is it a deformation? Is it a force? Is it a pressure? Guess the right answer. The solution is option B, deformation. Strain gauge is used to measure deformation of an object. We'll go for the next question. The next question is: dash is a measure of how much an object is stretched or deformed. Option A, stress. Option B, strain. Option C, pressure. Option D, tension. Dash is the measure of how much an object is stretched or deformed. Is it a stress? Is it a strain? Is it a pressure? Is it a tension? Guess the answer. The solution is B, strain. Strain is the measure of how much an object is stretched or deformed. So in strain, we are not only measuring the stretched one, we are also measuring the deformation as well. So force can apply in tensile, force can be applied in compressive. If it is of tensile, we are measuring the stretched. If it is compressive, we are measuring the deformation. Got it? Okay. We'll go for the next question. dash act as a strain sensitive transducer. Which among the following is act as a strain sensitive transducer? Option A, strain gauge. Option B, Bourdon tube. Option C, bellows. Option D, metallic capsule. Guess the answer. Which thing acts as a strain sensitive transducer? The solution is option A, strain gauge. Strain gauge acts as a strain sensitive transducer. We'll go for next question. Select the correct statements. Strain gauges are classified as number 1, mechanical strain gauge, second, optical strain gauge, third, electrical strain gauge, fourth, rosette gauges. Okay. Option A, statement 1 is correct. Mechanical strain gauge. Option B, statement 1 and 2 is correct. Is it mechanical strain gauge and optical strain gauges? Option 3, statement 1, 2, 3 is correct. Is it mechanical strain gauge, optical strain gauge, electrical strain gauges? Option D, all are correct. So strain gauges are classified into mechanical strain gauge, optical strain gauge, electrical strain gauge, rosette gauges. Guess the answer. The solution is T. That means all are correct. So strain gauges are classified as mechanical strain gauges, optical strain gauges, electrical strain gauges, rosette gauges. We'll go for next question. Dash is used to determine the strain existing at a point on a loaded member for the purpose of stress analysis. Option A, strain gauge. Option B, stress gauge. Option C, bellows. Option D, metallic capsule. Solution is option A, strain gauge. Strain gauge is used to determine the state of a strain existing at a point on a loaded member for the purpose of stress analysis. I hope you all enjoyed the session. I would like to conclude the session with a quote from Steve Jobs. He says, "Learn continually. There's always one more thing to learn." Thank you.